Good morning, students. A very, very warm welcome to all of you. I hope that you all had a very fun and a very relaxing vacations. So let's get back to studying, right? And we will start with geography for social science. So we'll start with the third chapter, motions of the earth, right? So what this chapter covers is students, it covers rotation and revolution, right? So there are two basic motions of the earth, rotation and revolution. We will be studying what is rotation, the effects of rotation, circle of illumination, duration of day and night. Then we'll get back to revolution and then talk about effects of revolution, aphelion and periphelion, cycle of seasons and summer solstice, winter solstice and equinoxes. Okay, so it's going to be very interesting, a very fun chapter and a very conceptual, concept based chapter. So make sure that you try to understand these concepts. Once you're good with the concepts, you're good with the chapter, right? So now students, earth has two kinds of motions, rotation and revolution, right? So when I say motions of the earth, what am I referring to? Rotation and revolution. Now rotation of earth on its own axis, right, is known as rotation. The movement, now what is this? This is this, can you all see this red line, bache? This is our earth's axis, which is tilted at 23.5 degrees. If you all remember, we studied this previously. So this axis of the earth on which the earth rotates happens to be tilted at 23.5 degrees, right? So rotation is the movement of the earth on its own axis, is known as rotation. Now revolution is, students, revolution is the movement of the earth around the sun in a path called its orbit, right? So this revolution, movement of the earth around the sun on a fixed path, is known as orbit. This is known as revolution, right, bache? So rotation happens on the earth's axis while revolution happens on the earth's orbit. And this orbit, students, if you can see this orbit is known as the orbital plane, right? And it takes 365 days, 5 hours, 48 minutes and 56 seconds to complete one revolution. And it takes 24 hours to complete one rotation, right? Okay, so now when I talk about rotation, bache, earth rotates from west to east. Earth rotates from west to east. And this axis is again tilted at an angle of 23.5 degrees. Therefore, now students, I want you to look at this very carefully and try to understand what I'm saying. If you can see my mouse, so this is the Earth's axis, right, which is 23.5 degrees. And this is the orbital plane. If you all recall orbital plane, this is the orbital plane, the plane on which the earth revolves around the sun, right? So now this is my axis, which is at 23.5 degrees. If you can all see, right? This is my orbital plane, right? So earth is tilted at an angle of 66.5 degrees on its orbital plane, while 23.5 degrees on its axis, right? Now when I say inclination of the earth's axis, what I mean is it is the tilt of the earth's axis which is always inclined towards the pole star. So this axis is inclined towards the pole star, right? And one rotation takes 24 hours, which is also known as daily motion of the earth, or the earth day, or the solar day, right? There are a lot of names for this, but yeah, and the inclination of the earth's axis, this is the 23.5 degrees tilt of the earth's axis, whereas on the orbital plane, earth is tilted at an angle of 66. This angle right here, students, is 66.5 degrees, right? So this is about rotation. Now, what are the effects of rotation, right? So Earth's rotation causes day and night, right, students? So it causes day and night. Then the speed of the Earth's rotation bache, has led now, because Earth rotates at a very I don't know if you all know this or not, but Earth rotates at an at, I think at the equator it is 1600 or 1500 kilometers per hour, right? So that is the speed by which Earth rotates at the equator, and because of this speed, right, there is a centrifugal force which is created that leads to the flattening of the Earth at the poles and bulging at the center. So it gives shape to Earth. So Earth's rotation causes day and night. Earth's rotation gives the Earth shape it has, right? It affects the movement of wind, ocean currents, tides, right? And the concept of directions, right? So Earth, because of Earth's rotation from west to east, sun rises in the east and sets in the west, right? So that's how the notion of directions, north, south, east, and west, has come into being. So yes, it has led to giving us directions as well, right? Now the circle of illumination, right? So now here on the corner is my sun, bache. One part of the earth has experiences day and the other part of the earth experiences night, right? So the circle here, in this case, the circle that divides the earth, right? Wherein one half experiences day while the other half experiences night, is known as the circle of illumination. It is an imaginary line. So, right, so some sun is coming from here, right? This half of the earth will experience day, right? And this half of the earth experiences night. So this circle right here, students, right here, if you can see this, yes, this right here is the circle of illumination. Okay. Now, students, when I say that the duration of day and night differs across the globe, why? Right? Once again, duration of day and night differs across the globe. Why? So now, this is because A, the earth is tilted at an angle of 23.5 degrees on its axis. So what happens is, bache, at any given point, either the northern hemisphere will experience more sunlight or the southern hemisphere experiences, in this case, the southern hemisphere is experiencing more sunlight, right? And here you can clearly see that the northern hemisphere is experiencing more sunlight, right? So, bache, what happens because of this is that when the northern hemisphere experiences more sunlight, it has longer days and shorter nights. In the northern hemisphere, when the southern hemisphere experiences direct sunlight, it causes longer days in the southern hemisphere and shorter days in the northern hemisphere, which means it's December in the northern hemisphere. That's something, although we'll come to seasons later on, but the fact is that the duration of day and night differs across the globe because the earth is tilted. And this is also the reason why, bache, North Pole and South Pole. So if you can see, North Pole, bache, and South Pole. So North Pole receives sunlight 6 months of the year, and during those 6 months, South Pole is its night in the South Pole. Whereas when the South Pole is inclined, when the sun's direct vertical rays are on the Tropic of Capricorn, right? South Pole experiences 6 months of daylight, while the North Pole experiences 6 months of nighttime. Right? So that is the reason why the duration of day and night differs across the globe on Earth. Right? The next part is we get on to revolution. So now what is revolution? Once again, revolution is the movement of the Earth on its orbital plane, right, while it revolves around the sun. It is also known as the annual motion, and it takes 365 days, 5 hours, 48 minutes, and 56 seconds to complete one whole revolution. Now, when I say how many days in a year do we have? We say 365 days. But what happens to these 5 hours? Right? So what we do is, for convenience, after every four sorry so after every 4 years, bache, we add these 5 hours 48 minutes and 56 seconds, right? So all of these hours are added and adjusted every fourth year as a leap year. So after every 4 years, that is the reason why you have one day added to February and you have 29 days in Feb, right? Making it 366 days. So leap year has 366 days. Why? Because it is these 5 hours of the previous 4 years that are added to make sure that we are on time, right? That is known as the leap year. Okay. Next is effects of revolution. Now, what happens because of revolution is a change of seasons, right? Difference in duration of day and night, difference in distribution of heat over the surface of the earth. Now, let's take up these, right? Um, one second, I'll explain seasons first. Maybe I'll explain aphelion peripheral. Okay, great. So I'll go with aphelion and peripheral first, and then we'll go to seasons, right? So, bache, aphelion and peripheral, right? So when now Earth's orbit is elliptical, right? It is not a circle; it is elliptical. It is kind of an egg-shaped, oval-shaped, right? You see this? Yes. It is. Is it equal? No, it is not equal, right? Now, when the Earth is closest to the Sun, right? I'll repeat, bache. When the Earth is closest to the Sun, right? That is known as perihelion. And when the Earth is farthest from the Sun, that is when the Earth would be somewhere here, right? That is known as aphelion. So peri means, bache, peri means near, and helios means sun. So peri means near and helios means sun, whereas ap means far away and helion means sun again. So when it's farthest from the sun, it is known as aphelion. When it is closest to the sun, right? When Earth is closest to the sun, it is known as perihelion. Yes. So when we have perihelion, the perihelion is always on 4th of January, whereas aphelion falls on 4th of July, right? So this is 4th of January, 4th of July. Perihelion is when the Earth is closest to the sun. Aphelion when the Earth is farthest away from the sun, right? So this distance is approximately 151 million kilometers, while this distance is 146 million kilometers, right? So 146 million kilometers, 151 million kilometers. So when we say average, on an average, what is the distance between Earth and sun? We say that it is 148.5 million kilometers, right? So it is not the exact figure because the distance between Earth and the sun keeps on changing, right? All right. So this is yes, aphelion and perihelion. It occurs on January 4th. Make it January 4th, students, when the orbit of the Earth is closest to the sun, which means Earth is at a minimum distance from the sun. Aphelion on July 4th, when the Earth orbits around the sun and its position is maximum distance from the sun, right? So now seasons. Now, students, see the hemisphere that is tilted towards the sun will experience warmer weather and a longer daytime hours, right? Whereas the hemisphere tilted away from the sun will experience cooler temperatures, shorter daytime hours, right? This variation in daytime hours and the average temperatures causes by revolution and tilt results in different seasons of the year, right? So now let me explain this, right, students? So now this is the sun, this is my earth. Okay, this is the axis on which it goes right about like this. Okay, now what happens is that when the Earth's sunlight, if you can see, bache, is directly following on the southern hemisphere, vertically following over the southern hemisphere. When this happens, you have summers in the southern hemisphere, and here on the northern hemisphere, bache, sunlight is indirect. That makes it winters in the northern hemisphere, right? While the North Pole is for 6 months, North Pole is under, North Pole has night, while South Pole has daytime, right? Now, when we look at June, what's happening is that you have summer in the northern hemisphere, direct sunlight over Tropic of Cancer, right? And while the southern hemisphere, South Pole is 6 months in, it has night for 6 months, right? Now we'll move on to the next part. So have you understood, Bache? This is how also for a fact that why during Christmas is summer in southern um, uh, in in Australia you'll have summers on Christmas, whereas in northern hemisphere it is cold, it is winters, right? It is because of this. It is because of this tilt, because of the rotation, right? That we are experiencing these seasons. Yeah, see, look at this. This is a better diagram to show what happens. So, can you see the students in December, Northern Hemisphere experiences, so direct sunlight and Tropic of Capricorn. So, Southern Hemisphere will have summers, while the Northern Hemisphere will have winters, right? In March, right, and April, you have spring in the Northern Hemisphere, while the Southern experiences autumn. Now, in June, July, what we have is that direct sunlight over Tropic of Capricorn, right? Southern Hemisphere experiences winters, and here it changes in September, October. What you have is northern in autumn in the Northern Hemisphere, whereas Southern Hemisphere as spring, right? Now let's talk about solstice and equinox, right, bache? So what is solstice and what is equinox? It is a very interesting concept, nothing major, right? So solstice is bache, the longest day, right? Solstice is the longest day in, and equinox is the time wherein the day and night are equal in length. So let me explain this once again. So summer solstice and winter solstice. So summer solstice is on June 21st in the northern hemisphere. So June 21st in the northern hemisphere, the sun is direct sunlight on Tropic of Cancer, right? And on December 21, you have winter solstice, right? So what happens is that so in summer solstice, I'll repeat, happens on June 21st. What happens is that in the northern hemisphere, it experiences the longest day and the shortest night, right? The position of Earth is known as summer solstice. Why? Because it is summer in the northern hemisphere, right? And the North Pole is inclined towards the sun. So sun rays fall vertically on Tropic of Cancer, and places in the northern hemisphere are experiencing summer seasons. This is something that I've already explained it to you, right? If you recall, similarly, what happens in the winter solstice is now places in the southern hemisphere experience the longest day and the shortest night. So winter solstice में क्या आता है बच्चे? The places in the southern hemisphere experience the longest day and the shortest night. Whereas during the summer solstice, what was happening? So the northern hemisphere was experiencing longest day and the shortest night on 21st June. During winter solstice on December 21, the southern hemisphere experiences the longest day and the shortest night. ठीक है बच्चे? Now what we have is equinox. Equinox is when the duration of day and night is same. Now that happens when the earth's sunlight directly falls on the equator. This is the equinox. So solstice is when summer solstice happens on June 21st. Sun's sunlight falls directly on Tropic of Cancer. Winter solstice happens on December 21st when sun's direct sunlight falls on Tropic of Capricorn in the southern hemisphere. This is on Tropic of Cancer in the northern hemisphere. And when the sunlight fall directly on the equator, it causes equal days and equal nights, right? This happens again twice a year, right? One is spring and one is autumn on 21st March and 23rd September. Now on 21st March, you have spring equinox, right? Also known as vernal equinox, but that's okay. It's not mentioned in your book. And in September 21, you have the autumn equinox. So that is your summer and winter equinox explained to you. Once again, on 2 days in the year, the sun shines vertically over the equator at an angle of 90 degrees. These days are 21st March, spring equinox, and 23rd September, known as the autumn equinox. You have autumn in the northern hemisphere during this time. The equinoxes, the days and nights are of equal length throughout the world. On March 21, it is spring in the northern hemisphere, and on September 23rd, it is autumn. And the positions are reversed for the southern hemisphere. So when you have, right, so I mean, because we are in the northern, so this is summer and winter for us, right? What I mean by this is that, for example, so when we're here, it would be, what do you call, summer, it would be on 21st March, it would be spring equinox for people in the northern hemisphere, while it would be autumn equinox for people in the southern hemisphere. But when on September 21, it would be autumn for people in the northern hemisphere and spring for people in the southern hemisphere, right? Now with these students, we've completed this chapter, and I think you've understood all about seasons, you've understood all about rotation, revolution, and this is a very interesting chapter. A very once you've understood this is not much. I hope you've enjoyed this as much as I enjoyed teaching this to you. Right? Thank you.